Welcome to BeeGraphy. My name is Asim. I'm an architect and a computational designer. We are starting off with the intermediate level tutorial series now. In this series, we are going to look at more practical outcomes and the scripts are going to be a bit more challenging. But don't worry, if you have completed the Beginner BeeGraphy series, you are well equipped to follow along with me in this series as well. So whatever nodes and concepts that are going to be new that have not been covered in the beginner series, I'm going to explain that in detail. So don't worry, this intermediate level assumes that you only know the basics of virtual scripting, you know the basic interface of BeeGraphy. So without further ado, let's begin. So in today's tutorial, we are going to look at parametric spiral staircase. It is slightly different than the traditional spiral staircase, which looks like this. A single vertical member running in the middle, and then we have got the steps spiraling upwards. See? Things like this. So before we begin with this tutorial that I'm going to teach, I would like to give you a challenge. Try to script a very basic geometric outcome of this spiral staircase. Very simple, just a vertical line. You can use line SDL or take 2 points and then connect it with a line. That will be your vertical member. And then figure out how to create a step and then rotate it throughout this line. I'll give you some hints. If you remember the parametric twisting tower, some concept will be taken from there. You'll use sequence to generate a series of numbers that you're going to input in the rotation of these steps. Don't worry about the exact shape of these things. Just take the basic geometric element like line, rectangle as steps and just spiral it upwards. Alright, so that will be a challenge for you. Do that, and I'm going to show you how to do this one. This is slightly different. So in their website there is EE stairs, and it's called 1 meter square stairs because it boasts that it just requires 1 meter square of area, a cuboid of a square of 1 meter square, and then a cuboid throughout the height of the building, and you can have a spiral staircase, which is very efficient and more ergonomic than the traditional spiral staircase. So you can see that the vertical member is slanting, and you can also see that the entire thing fits in a cuboid instead of a cylinder that is in the traditional spiral staircase. You can see cylinders, circles, but this one is in a cuboid. All right. So we've got this line, this structural member coming from one point of the cuboid to the other point of the cuboid, and then these steps are simply running around it. So let me sketch this and show you. So we've got a cuboid. Let's make a cuboid. All right. Something like this. All right, and then if you observe the vertical, the structural member is from this point to this point and not behind it, right? Let me change the thickness if I can. Right, so this is behind it, but the structural member is in front of it. Now the steps that are there, they are like this. And then we end up over here, right? So I think I've made a mirror image, which is fine. Yeah, in this one it is from bottom left to top right. In our case, I took it from bottom right to top left. same case, just a mirror image. But you get the idea. The diagonal isn't across the cuboid, it is just on one face. So how we're gonna proceed with this? First of all, let's break it down. First of all, we are going to have a cuboid, sorry, and then we are going to extract all these geometries from it. So we've got the cube, then we'll extract this point, we'll connect it to get the structural member. Then we are going to divide this structural member to create the start point of the steps. And then I'm going to detail out how to rotate these sequentially, correctly, and the finer nuances, how to give it thickness and all of that stuff. But this is how we will begin. So with that out of the way, I will quickly show you a script that I've already prepared. It's a much more elaborate. We won't go that deep for now. I'll leave the fine-tuning for you to explore. All right, so I'll just demonstrate what this script can do. The depth is variable. So if I increase the depth, it automatically calculates everything and gives us the outcome. So it is not restricted to that 1 by 1 meter square area. You can change the width and even reduce it, and you get this. Now I have kept my script such that I can increase the height of the building, and automatically it will increase the number of steps so that the riser, the height between steps, is not too much. Remember, I said that we will divide the line and then do it. If we divide the line, then we won't get it. But you can figure this out. You can figure this maths on your own, how to make the steps, number of steps, increase with the increase of height. All right. We can, of course, control the thickness. We can control the inclination of this structural member. I'm going to go through everything. And in the script, I'll just show you, we can see that we've got the box, we are deconstructing it, we are extracting surfaces and points, and then we're going to use it. So of course this script could be a bit overwhelming, but I'll break it down and take it slow. All right, let us begin with our scripting. First of all, we will have our box. Okay, we're going to work in millimeters. So let me increase this size. So let's have 1,000 as the width and length, and the height will be the height of the floor, which can be 2750 for now. Awesome. Now what you're going to do is we are going to deconstruct it. Deconstruct solid. From this we get the point, we get each individual surfaces as outcomes. We even get the curves as the outputs. Now what I want is I want to eliminate the top, bottom, or let's say just the top and the front part to create an opening. Like we see in most cases, it's in this case it's completely open, but yeah, in this case it is like enclosed from left side, bottom. We'll create an enclosure by eliminating some of the surfaces. Now for that we have got remove by index. Now if you remember, I talked about this data, how data flows through these wires, right? Now this is what is flowing through it. If the line is slim, it means only a single data is flowing through, either it is a number, in this case it is a solid. In this case there are surfaces going out, 6 surfaces, and that's why the line is thicker, the wire is thicker. And this is called a list. These are a list with all these items. The item could be anything, surfaces in this case, and this is called index, the rank, right? So this is the 0th item, first item, second item, and so on. So we are going to put this list here, and then I'm going to mention some index, and it is going to remove that item. So 0th item has been removed. All right, we need to hide this to see that. Where is it? Where is it? We need to hide the box as well. Perfect. So 0th one is this one, and I can show you what 1 would do. 1 is removing this one. I'm just going to put in 2 and put that in index so that we can have more numbers of testing. Also, right now you can see that when I change the number, nothing changes, but when I click outside, then it works and has removed it. See, I've changed it to 2, but this is still here. But when I click outside, then it is registering the change. If you don't want that, go to settings and then go to live calculation and toggle it on. Again, go to this BeeGraphy icon, settings, live calculation, turn it on. So now when I change it, when you use the number slider, then it works instantly. So this way you can easily check. I'm just trying to see my I'm trying to orient this in such a fashion that we have to deal with the positive numbers in x-axis. So this is good, and then we are going to select this as the front face. So 2 is the number that we want. Let me remove the top part as well. I'm just going to copy paste this, press shift, and then see what number removes the top. So 5 removes the top, 2 removes the front. All right, this will act as floor, and let's keep these two side by side. All right, so now this is my list of surfaces. Next, we are going to extract points to get these 2 points, right? To create that structural member, either from top left to bottom right, or the other way around. As you can see here, both ways are possible. So let's take this one, bottom left to top right. What I did was I wasn't able to see the points, right? So instead of turning it on and then seeing everything, I just wanted to see the points. So what I did was click, drag, leave, and select relay. Now relay is something which is pretty useful for wire management, doing things like this, just previewing on the points and nothing else. So yeah, I did that. Now, in the previous one, we had a large number of surfaces, 6 surfaces, and then we had to remove 2 of them. But now we only want to select 2 points. So for that, we are going to use item. Wait. We are going to select list item. So I'm going to put this list of points inside, and then when I change this number, you see, observe here, you see different points are being highlighted yellow as I'm changing this number. So I'm going to put in range input. We need 2 points, so I'm going to put 2 range inputs, one here, then again here, and now I'm going to cycle this to see which one is being selected. Now you can hide, actually you can just double click on relay to remove it, and you can double click on the wire to add the relay. But that time I did not have a wire, so I had to do this and then take relay. All right, now we don't want the relay because the relay was displaying all of the points. We just want to see the 2 points that we want. Right, so now this point is jumping. Awesome. 1 means bottom left. Now I want top right. Yeah, 4 is top right. Now if I connect these 2, I will get the line that we want. All right. we need to split this up because we want separate points to be put in this line. All right, we've got this pipe, this structural member. Also, you can see that it is slightly offsetted from the actual point. So let's fix that. We're simply going to move. Take this geometry. This is x-axis. So I'm going to take an x, vector x, put it here. Move is pretty easy. You all remember. I'm going to put in some number. Let's take 150 mm, which is 6 inches. And you can see that this has moved to the right. The top right point, that needs to move towards the left. I'm going to do a small trick to reduce the number of nodes. First, I'm going to show you the hard way. Right, I'm just going to take this here. I'm going to put this over here. Yeah, so what I did was, again, I had one point. I moved it x positive and it moved here. I take the same thing, put it down. So it is moving on the right side. And at the end, I'm just connecting the point. But we want it to move towards the left side. So we are going to add a negative node, which is called opposite in BeeGraphy. So we're going to take this number, make it go through that, and we have got the desired outcome. So now how to optimize the script, how to reduce it. We can use the same thing over here. Oh, sorry, I can just not press shift. All right, so one node is removed. Then we could say, can we do the same thing for a vector? So what if we put both the points in the same move and then we extract the points again and put it into the line? So let us do that. I'm going to use just one vector x. I'm going to put both of them inside. I'm going to just use move command. I'm going to put both of them inside. See what's happening? 2 points getting in this geometry and 2 values, one 150 and the other one minus 150. Both of these data are being corresponding, or both of this data are merging in this move command, right? 2 points are going in geometry, 2 values are coming in vector, and then those values are corresponding to these 2 geometries respectively, and that is why that is how we get these 2 points correctly coming outside. Now again, of course, we need to extract the 2 points separately, so I'm going to use list item, 2 of them. There are 2 items, so 0 and 1, and then I'm just going to connect this 0.1 and 0.2. Pretty obvious, right? 2 points coming outside. List item takes the first point, this one takes the second point, and then we just join the line. So like we say many times, in computational designing, there is no single way of doing something. There are innumerable ways to do the same thing to get the exact same outcome. All right, so this has definitely reduced the number of nodes. Now let's pipe it, give it some thickness. Right, so just type in pipe. It requires a base curve and a radius. So let's give a radius of 50, should be good, 5 centimeter. All right, so we've got the pipe, we've got the surfaces. Let me organize the script. Now that we are moving ahead, let us organize it so that it's easier to navigate. You know, when you have to take some value from the past node, it's much easier when it is properly arranged. Right, so now this is clean, and let's keep it here. So this is giving me the walls. So let's type walls here. Um, let's group it. Select everything. Control G. Zoom in. You can type in walls. All of this is creating the walls, and you can move the entire group by selecting here. Oh, you see, accidentally I got this node in this group. So what you can do is select that node, just like click it, then right click on the group and remove from group. And now this thing has been removed. I'm glad that happened. All right, so this is walls, and then this would be the, what do we call this? Pipe structure, or just pipe is fine. There's only one pipe. Awesome. Next, this pipe is only for visual purposes. When we are creating those steps, we are not going to use pipe. We're going to use the line, the core geometry, to extract the steps from. All right, so now we start with steps. We are going to divide this line. For now, we're just going to divide it, and then originate these steps to create the stairs. So we will do divide by count. You see, there are several divide. You can try different things out and see why other things are not optimal. For example, there is divide by length, divide by distance. In divide by length, what happens is you can give it 200 millimeters. So it will continue dividing the line equally by 200 millimeters. But if the line itself is not a multiple of 200 millimeters, let's say it is 1100, then the last step will only be 100 millimeter high. So we don't want that. Even in reality, I'll show how this number of steps are calculated. So we as architects, we know the guidelines of how much high and how much thick the steps should be. So this is called a tread, T-R-E-A-D, where the foot lands, and it's ideally 1 foot in depth, which is 300 mm. Whereas this is called a riser, the height of the steps. This is a riser, right? Riser. And this is ideally 150 mm. All right. Now, when you are making the building, let's say this is the building, and then there are several floors. What happens is, many a times we've got these slabs laid out first, and then we put in the bricks to expedite the work. But the bricks height is fixed. So let's say, as an architect, I want the precise height of this one to be 3.2 meters. The bricks might end up, let's say, at 3.17 meters, some random number. And that makes it very difficult for the steps to match that. Not only that, there is tiling, then there is some material beneath the tiling, and even for the work that we are doing, there would be some layers on the steps itself, there will be layers on the flooring and the ceiling. So that is never accurate. So what happens is, after we finish it, the finished outcome, we measure it, whatever it is, and then we simply divide it to find the number of steps. Let's say we divide it by 18 number of steps, and then we check what the riser would come out to be. So many a times it comes out to be 166.7 167 millimeters, 166.666 millimeters. So that's not good. So let's make it 20 and then see what happens. It comes out to be 148 or something millimeters. Then that's good. We take it. So we are going to divide it equally into 20 steps, right? So we work with number of divisions and not by exact 150 millimeter steps. So yeah, sorry for the tangent, but I think this is good information for everybody. Let me get back here. Alright, so we divide by count, not by length, not by distance, by count. So I'm going to take this line, the line inside. Let me hide the pipe so that you can see the line. And then by default, it is dividing into 4 parts. Now, very important. Very important. You see, it is divided into 4 parts. 1, 2, 3, 4. But how many points have been created? You see these points? How many points are there? That's 1, 2, 3, 4, 5. 5 points. Count 4. So remember this. Alright, the number of points are always one number more than the number of divisions. So this will be very important for later. Right, keep that in mind. Now let us give some number. Let me give 11 so that I can get a larger number. Alright, so let's put 11, or let's say 10. 10 divisions in this line. Now what I'm going to do is I'm going to create the steps from here. For that, I'll first explain the idea. I'm going to create lines that spiral originating from this point and going like so. Okay? And then I'll use that line as my original geometry to create the step. And how I'm going to do that is I'm going to rotate all of these lines again slightly. And then we are going to do some operations to make it into a surface. Sounds simple? It is simple. And then we are going to extrude it to give it some thickness. As simple as that. So let's create lines first. All right. So we are going to use line SDL. You see there are 2 types of lines. We have used normal line a lot. We need 2 points, but in this case we know the original origin of the point, but we don't know where it will end. So the origin is all of these points. If I connect that, I get very small lines, which is just 20 mm in length. Let's fix that. Let's take 2 meters. I want it to exceed beyond the cuboid so that then I can slice it off. Alright, and then the vector, we need direction. Line SDL means line start, direction and length. So point gives me the start point, vector would be the direction, in which direction you want to go, and then the length would be how long the line should be. So let's put in vector as something uniform, simple, x. Oops. Awesome. Now I'm going to rotate them sequentially like we did in the parametric twisting tower in the previous series. Let me remove this line. Rotate this one. So these are all the geometries, and then we are going to rotate them. Let me take degree to rad first. I always forget that. I'm going to put it over here, and then we are going to put some degree over here to see if it is working. I'm going to hide these lines. I'm going to keep this. So all of this is being rotated around the origin. Again, a reminder, if you're not able to see the input and output live, that is because you haven't turned on the live calculation. So go to BeeGraphy icon, settings, and live calculation, turn it on. All right. So this is rotating around the origin. We don't want that. We want the lines to rotate, each line to rotate around their point of origin. So very easy. We're just going to take this point, which is the point of origin, and put it in center of rotation. So that will become the axis of rotation. Now let's see. Perfect. Now we want them to rotate sequentially. How are we going to do that? Pretty easy. We are going to create sequence node, list sequence, right? Start 0, count will be the number of steps we have, which is this. No, sorry, which is, where are the number of steps? This one. All right. And let's just put in 15 degrees for now. And then put this here. Awesome. We have already we are already getting close to the final outcome, but there are few issues that we need to solve. First of all, we do not want a step over here. So we'll fix that. We can see that things are rotating, but for the last two steps, they are exactly the same. You can see this. All of them are spread out, but this last two are the same. Now this is happening because there is a difference in number of geometries going into the rotate node and the number of angles going into the rotate node. You want to check it out? You can go to panel. You can see length 11. You can go here, panel, length is 10. So we are getting 10 number of angles but 11 geometries. So the first 10 geometries are getting 10 odd different angles, but then the last geometry is like, where's my angle? So the geometry that's just before it is sharing the same angle again with the last geometry, and that is where the issue is arising. So fix is simple. Either you reduce the number of point, but you can't do that actually. If you reduce the number of count, you will reduce the number of these angles as well. So we are going to increase the number of angles by 1 in this list sequence so that you get another angle. There is a shortcut, just do +1 and click on addition. So by default this will come with 1 inside B, and then make this go through here and make this count. So what happened? Like, we are putting 10 count in division, why are we getting 11 outcomes? If you remember, I told you that the number of points is always 1 more than the number of divisions, right? If you divide a line into 2 parts, you get 3 points. So if you're dividing into 10 parts, you're getting 11 points. And instantly this is fixed. All right. Now we want to figure out how to land this last step correctly, right? You want it to be horizontal, like it has started horizontally, it should rotate and then go back to its horizontal state. And it is not 360-degree rotation, it is 180, right? Starts from here and then 90 and then 180. So it's pretty obvious. We are going to divide 180 by 11, the number of divisions that's happening. So we're going to take 180 divided by, again a shortcut. Oh, it did not happen. All right. I'm going to just put in 180 and put it here. But if you do like divide by 3, then this comes here by default. Otherwise, it will be empty. All right. So 180 divided by the number of points. So instead of putting in 11, then when you change this, you put in again. What you can do is simply take this one, which is already 10 plus 1, and put it over here. The outcome will go into the step. So we'll move it back, remove this, put it over here. Oops, put it over here. So there is an issue which is actually pretty good. So we have got 180 divided by 11, and then all of these angles are going up, and you can see that the last line is like this. Now, I mean, we wanted a flat line, but this is actually even better. I will explain you in a bit, because what's happened is now we are actually going to create steps for which we are going to rotate them again slightly. So at the end, when we rotate this again, we will get what we want. So even though we were thinking of getting a straight line, we got a line which is a few degrees behind it, but that's the desired outcome. So the blessing in disguise. I'm going to rotate all of these lines again, and I'm going to rotate them. Actually, why not just copy this, because it has all the centers, geometry and everything connected. The angle will be the step. Oh, sorry, it should go through degree to radian. Always keep that in mind. You see, it's exactly landing horizontally on the surface. So, I mean, this actually opens up a new discussion topic, which is really important, is that instead of trying to figure everything out, all the math out before starting to script, just start scripting and fix things as you go. Because like if I had sat down, trying to figure out the math, then even without actually drafting it, I would have realized that, oh, my step would actually not land at 180, it will land behind that, and then I would be stuck, and I would be thinking what to do, how to fix that. But now when as we are like going through and adapting, as we are scripting, we just saw that it is actually useful. Awesome. So we've got all these steps, and we are going to create surfaces so that the step is created. We are going to do that by there is a node. Now there is a long story behind this node, which is, so what it does is it divides two surfaces. There is surface difference, and then there is I can't find it. All right, I'll just type in surface difference. So there is surface difference, and then there is I can't remember the name. Surface intersection. Yes, intersect, solid intersection, region intersection, intersect surfaces. All right. So it is not surface difference. Now, I mean, I'm going to leave this out. I'm not going to edit this out, because this is how you try to find out without going through blogs. If you want to just do something. So let's say you want to intersect these lines with the surfaces. How are you going to do that? You type intersection and you get all of these nodes. So before making that script, I have experimented with what works, what doesn't work. So none of these things worked for me. Solid intersection, I tried to make the box as a solid and then tried to intersect it, didn't work. Surface intersection, region intersection, play with them and figure out what works for you. I did not have the script handed over to me, right? So I had to figure things out on my own. So intersect surfaces worked. In that, you need two surfaces. One will be all the boxes. Yes, and surface intersection is completely different. So there are two surfaces, and if you intersect them, the part that is intersecting will be the outcome. So that's not what is required. So we want surfaces as inputs for both of these things. So we need the surfaces of steps and surfaces of the walls. Now we don't have steps as a surface, so let's create that surface first. So we have created the two sides. What I'm going to do is I'm going to join all these endpoints to create a triangle, and then we can create a surface out of it. All right, so we want to extract points, so let's do endpoints, and I'm going to put in the curves. So this is the rotated curve and these are the unrotated curve. We've got these 2 points. I'm going to use relay to check. Yeah, so this is not the one that we want. We want these 2 points. So this one, oops, sorry, this one will go into one point of the line. I'm just gonna guess. Yeah, you can just do trial and error. All right, so this has become a triangle. Now there are 2 ways to create the surface. One is extrude point. So let's use that. For extrude point, you've got a profile which is this line, and then it is gonna, oh yeah, it has already done it, and then it is gonna extrude it to a point, which in this case is the origin, but we want that point to be these points, which is over, can't find it. Oh yeah, we divided, so divide by count and this point. Yeah, this will go over here. Awesome, so we've got the step surface. Now we've got these surfaces. Let's put that here, and we'll take the box. Where the box, this box, and put it over here. Keep in mind I did not take the walls outcome, which is exploded and all these surfaces are different. It might mess it up, so I just took the box and took it over here. So what this does is you can see all these new points that have emerged. So these are the surfaces, intersecting surface. Let me hide everything else. Now we are intersecting it, but it is not giving me output as a surface, it is giving me curves as the output. So I'm going to convert the curve to surface. So curve to surface is the command. Do that. Oh right, we need to make it closed curve. These curves are simply lines. We want them to be triangles. So let's join them and then put it to curve surface. Perfect. We've got the steps, we've got the pipe, we've got the walls, and we are almost there. Thickness, let's give it thickness. Extrude surface, vector Z, let's give it 18 mm. That's the thickness of plywood. Right, so we've got the thickness, and let's quickly do some cleaning up. Let's give thickness to the walls. Where is the wall? Yeah, this one. So we'll do material, apply material, put that over here, give it a nice beige color, and hide this wall. And even before that, actually, let's first give it thickness. Now the thing is, if you're extruding it, we need to extrude it in positive x, negative x, positive y, separately. So or we can simply do side thickness, which is not ideal because it will go both ways. I'll show you what I mean by that. You see what's happening. Oh, it's going only on the inside. Perfect. So let's just put in opposite over here, and it will go outside everything. Let's put this into geometry and then hide all of this and reduce this to 115. It's not as clean as what I made. In my case, it's nicely curved. I can show you a glimpse of the script, but do it on your own. Some key things are offset curve, offset type arc. Yeah, that's all. Then figure it out on your own. It will be a nice small challenge for you. All right, so we gave some thickness to the walls. Let me get the pipe back on. But I'm going to apply material. You're going to make it metallic. I like this rose gold color that emerges when you put metallicity to 1 and roughness to 0. See this nice color. Let me move this slightly to the right and clean this up so that it is more readable. I'll be sharing the script in the description. You can get the link, and I'll show you how to share your scripts for collaborating or sharing it with your friends. It's pretty convenient. All right, so this is how you arrange the script for better readability. Minimal intercrossing wires. Remove these panels. That was for just basic understanding. So that these wires aren't confusing. You just space it out in such a manner. All right, now we are going to group them. So this entire thing is actually for the steps. So let's just group it up as steps. And let me hide all these points that you can see. Oops. Also, to unhide something, you can just click on this eye and that unhides it. What are these points? Right click, hide. Still not gone. Okay, this one. Yeah. Still there is something like this point is still there. Trying to search it. No. Interesting. When you select something, it should appear. Let me just refresh it. Probably it's just a glitch. Yeah, it was a glitch. Awesome. Now we are going to do the final fine tuning. So you see, we don't want this step. It's not required because it is coinciding with the floor. So what you can do is remove that step. I won't do it. You do it. You can do remove by index like we did for the entire box, removing the top and the front. Remove by index. Figure out where to put this. All right. A hint, you can put it after join. And then select the number which will remove it. Actually, I'll just show you. And then just put in a number. And then put it over here. So one of the steps should be removed. Oh, right, you have to flatten this first. Flatten. Now this one is removed. Awesome. So 0 would actually remove this step. But yes, I mean, I haven't fixed your problem. I've just scratched the surface because you need to figure out because this step should start as a horizontal. It shouldn't start with already having an angle. So you need to fix that. You need to probably take a negative start point, but if you do negative, then this entire thing will rotate a bit, so that's not the solution. So you need to figure out how to fix this properly. I just gave you a glimpse. Fix that and share that in the comment section. Share the link to your script in the comment section. I'm just going to add apply material to the stairs. I think white is fine, or you can have it black. So that's first challenge for you. First challenge was actually just create that spiral staircase. I hope you did that. Share that in the comment section. Second challenge is to do this, what I just asked, to fix this step, but not just remove it. Remove it in such a fashion that the rotation gets fixed. Thirdly, you see this is overlapping. You want to cut this out. You want it to intersect and cut it out. So figure out how you're going to do it. Intersection, solid difference, surface difference. Just play with all of these different nodes and cut out all these small spikes that are going inside. Of course, you can't see it, but that makes for a cleaner geometry when you export it. So figure that out. Now I'm going to show you how to share things. So you can see that I've renamed it into Intermediate Tutorial 01 Spiral Stairs. So when I go back to my workspace, I search for Intermediate Tutorial 01 Spiral Staircase. I go here, and then you can click on Share. You can give access as viewer or editor, and copy link, and then just paste it in the comment section or message it to your friend, and this will open up. Then you can see the entire script in detail. You won't be able to change anything, but you can see it. If you do edit, then you can, the other people can change your script. So keep that in mind. So that is all, I think. We've got this parametric spiral stairs, and hope you followed along. Do the 3 things that I asked you. That's gonna be fun, because the more you do, you'll get more doubts, and you can ask those doubts, and I'll definitely try to respond them as soon as possible. So go ahead, try it out, and see you in the next one.